so let me share my screen. Okay, so let us just go over some terms based on what we have discussed, and we'll take a further look into the idea of multi-level. So fixed effects. Now there are two ways for economists. What they do is they use dummy codes for level 2 IVs and include it directly in level 1 models. So for example, the question that Kanika asked, we can use dummy codes and do it for psychologists or in management disciplines. Fixed effects typically model the overall effects, and we do multi-level models that give us the fixed effects, give us the overall intercept and the overall slope. And then we also have mixed effects, which is a combination of fixed and random effects. Mixed effects, so multi-level models are also called as mixed effects model, where there are fixed effects as well as random effects. Random effects are essentially telling us how much is the variation of the intercept or the slope for different groups that we have had, right? Different groups and different L2 grouping variables. So it accounts for modeling the nested structure. And so we have mixed effects are models that have both fixed effects and random effects. So just keep this in mind when we start writing the models mathematical formulation. I will explain again what is a fixed effect and the cross level interactions when L2 variable impacts the L1 relationship. That is when we have interaction, and it is called as cross level interaction. I will explain that again. And cross level direct effect is in general the effect of the higher level IV on lower level DV. So let us look at examples, okay, and let us look at the terminology. So N level modeling, right? This is a question that some of you were asking earlier. Okay, so you see there is individual level self-efficacy impacts performance, team empowerment impacts group performance. So it is just, you can say, two level modeling. Okay, there is nothing cross level or mixed effects or multi-level. There are no such terms used here. I just regress individual performance on self-efficacy. I just regress group performance on team empowerment, and then I am done with it. There is no multi-level modeling. Now this is multi-level modeling. There is individual performance impacting or self-efficacy impacting individual performance, team empowerment impacting individual performance, team empowerment, group performance. And you see here they have shown that there could be also an arrow that goes from individual performance to group performance. However, let me tell you again, this arrow is not modeled in the multi-level models that we will be studying. We always model a higher order. So from team empowerment to individual performance is fine. Team empowerment to group performance is simply a level 2 relationship. Okay, but saying there is a L1 to L2 path, that is something that is not really done. Now this is a relationship between group level L2 variable, okay, and so team empowerment impacts individual performance. This is all right. And people who are familiar with moderation, we always draw an arrow on the path or relationship which it is supposed to be moderating. So you see the L2 variable now moderates the relationship between self-efficacy and individual performance, which is at L1, right? So this is cross level, and also we will be modeling interaction term. So you can have an interaction between team empowerment and self-efficacy. This is also possible, and this is how it is drawn. And we'll look at this in our examples also. And this is a frog in the pond model. Okay, here I said self-efficacy. Okay, overall self-efficacy, but frog in the pond says it's the idea is that the smaller frog, okay, in a big pond will have lesser effect. Bigger frog in a smaller pond will have more, you can say, impact or more say. So what we do is you actually take the difference from the mean of the IV. So self-efficacy relative to group mean. This is only telling us how much do I vary from the mean. So I have removed the, you can say, the impact of the absolute size. I have kept only the relative size. Now, now I can get the actual effects of individual differences from the mean on the performance. So that is what which we can also possibly do. Multi-level statistical models. We have talked about this. You must justify the use of multi-level modeling technique. You must talk about why you are doing it. So you must be very clear what are your L2 variables, what are your variables that you are interested in, then aggregation. So when you aggregate, so there was this question that if I aggregate leaders' mindfulness and bring it to the group level, then you must have theoretical reason. You should have collected data, of course. So you should have designed the study, measured it, and there are some indices. So we will study three indices. ICC1 is not necessarily, yeah, okay, we can say we'll study three indices that will tell us or that will be used to understand whether aggregation is needed or not. So ICC1, ICC2, intra-class correlation coefficient 1, intra-class correlation coefficient 2, and RWG. RWG is within group reliability. R stands for reliability or agreement, and WG stands for within group, RWG. Okay. And there are two ways which I had talked about earlier, which is regression based. This is called as RCM, random coefficient models. Okay, or you can have SEM based techniques. Okay, but we will focus more on the regression based analysis in this workshop. Okay, it is random coefficient modeling, or you can say regression based multi-level models are extension of general linear models. Outcomes of interest are measured at the lowest level. So again, I want to remind you, let me go back to this, that outcomes of interest that we are trying to explain are all measured at the lower level, at L1 level, not at L2 level, because L1 to L2 is not possible to explain. L2 to L1 is something that we can model. Okay, intercepts as outcomes and slopes as outcomes. So we can both estimate randomness, what is causing randomness in intercepts, what is causing randomness in slopes. So that is something that we will study. Now let me just take you through this example. What do I mean, or what is meant by intercepts as outcomes? Now let's say we are talking about group team empowerment impacts average individual performance. Okay, so we are talking about groups team empowerment, which is level 2, impacts the individual performance. Now, when I say intercept, I am saying average. What is the average of the L1? So this is generally the notation Yij, okay? Yij, which is my individual performance given by beta 0j, beta 1, xij, eij. So now beta 0j, I can say is some overall mean plus a variation. Now what is U0j? So you see this is the this is the overall regression line, which is beta 0 plus beta 1 x1 ij or xij. And I say you go, this is for group 1, okay, or team 1 or school 1, and there is a difference in intercept. You go below, this is, so what is u0j, u01 and u02 capturing how much is the intercept of team 1 line differing from the overall intercept. So that is what it is capturing from the overall mean, which is beta 0, which is the overall intercept. What is the variation for each team? So you can see team 1 is high in intercept, team 2 is lower in intercept. Okay, and we say that there is all these U0J terms have a normal distribution with a mean 0 and sigma square U0 as its variation, and the error terms, overall error terms, again have a mean 0 and they have its own errors, have their own variation. So if you see individual performance and self-efficacy, we say team empowerment impacts individual performance. So these intercepts are telling us average individual performance. So you see team 1 has higher individual performance as compared to team 5. So the intercepts are different. Intercepts as outcome. So this L2 variable is explaining what is causing the difference in the intercept. So these are called as random intercept models. Random intercepts. You see that the slopes of the line are all same. They have the same slopes, but the intercepts are different. They exhibit the same relationship between individual self-efficacy and performance, but their intercepts are different. So for each team, the average individual performance is different. Now let me say that I want to ask this question, that the group team empowerment moderates the relationship between self-efficacy and individual performance. And this is the diagram that I draw. So there is a moderation because of the L2 variable. There is a moderation because of the L2 variable, and this is how I draw that there is a relationship between self-efficacy and individual performance, but it is moderated by the team empowerment. Now, how will the relationships look like? Now, you see, this was the overall, you can say overall line. So there was an overall intercept of beta 0 and an overall slope of beta 1. So this was the slope beta 1. Now what am I saying? That the intercepts are varying and U0j is capturing the change per school or per team or per group, right? Whatever your grouping variable is. And beta 1j, now beta, so you see it is beta 0j and now it is beta 1j also. So the slopes are also varying for different groups, and that is overall slope plus its variation. Now you see for school 1 the intercept is different, which is captured by this difference, okay, And then I am saying, what is the slope? The slope is what was beta 1? This was beta 1. This was the slope. Now I have u11. This is the difference from the overall slope. Similarly, u12, this is the difference. So there is a negative difference from the overall beta 1. So I have, what do I have? I have variation in the intercept also. I have the variation in the slope also, and my L2 variable is explaining this change in slope. And we say both of them, u0j, u1j, have, they are normally distributed, they have a mean 0, they have their variances, and they are also correlated to each other. Okay, so sigma u01 is capturing the covariance between these two residuals, u0j and u1j, and the overall eij continues to have a mean 0 and its variance. This is the diagram which is shown here, individual performance and individual self-efficacy. And now you see the intercept is, we can say the intercept could be common, same, but the slopes are different, right? There is one intercept, but slopes are different. You can have a situation, team 1 has high team empowerment, but still the same average individual performance. The slopes are different, okay? Team 1 self-efficacy is positive related to performance, whereas for the low team empowerment, Team 5 self-efficacy is negatively related to performance. So there is a random slope. And then you can have both intercept and slope, and this is what this diagram is showing us, that the intercepts are different, slopes are also different. This is the variation in the intercept, okay, and this is the variation in the slope, right? This is all that we actually try to model when we are doing multi-level models. We try to explain how the relationships that we are interested in changes for different groups, and what are the variables that predict this change in intercepts, okay, and the slopes. Okay, so this is the, you can say, overall uh, chart, which this is showing only varying intercepts. This is your dependent variable at L1, and this is your L1 predictor. And this is what I have written, or what is written in the figure: example of intercepts as outcome and intercepts and slopes as outcomes, okay, for 3 L2 units. And this is again dv with respect to L1, and now you have both varying intercepts as well as varying, so you see the intercepts are different, and obviously their slopes are different. Okay, any questions? Is this okay? Now let us go to the next thing, which is writing our multi-level models. Now let me take you to how do we formulate mathematical models, and what are the steps that we will be following when we do multi-level models. So I will come to the presentation later. Let me go to the whiteboard. Okay, and let me talk about what are the general steps that we will follow when we do multi-level models. Okay, so let us write Let us call this as multi-level modeling steps. Okay. And let us say we want to do model something like this. So we say Xij impacts Yij. Okay. And let's say there is a Wj. This is our L1. This is our L2. Now we understand these terminologies. Okay. We are saying that there is L1 dV. This is our dV which is at L1. This is our IV at L1. This is our IV again at L2. And we want to do this. Eventually, we will want to come to the mathematical formulation of this diagram. So what are we saying? This arrow is actually telling us random intercept model. This arrow is telling us random slope model. So we have a random intercept as well, and we have a random slope model also, right? That's our, let's call this as our conceptual diagram. Okay, and let me write this as the full title: mathematical formulation of multi-level modeling. Actually, yeah, it is okay. Of steps. Okay, right. So the first thing that we do when we, the first step, let's call this as step 1. And the step 1 is what we say is null model. Okay, the first step that we model is called as a modeling a null model. Now what is a null model? Let me write the equation and then I will explain. So the null model is written like this: Yij is equal to beta 0 j plus Rij. We can say it could be Rij, or some books you will study, it could be written as Eij. Both are the same. Okay, so you can, beta 0j is the others notations are very standard. Some books say Rij, some books use Eij, but they are essentially the same. So this equation is called as a L1 equation. So what am I modeling? I am saying that I am regressing dV on no independent variable. I am just saying there is some overall coefficient, okay, some overall mean plus a residual. And I say beta 0j is given by gamma 0, 0. So these are very standard notations, plus u0j. So what am I saying? Gamma 00 is, you can say, the overall intercept. Remember this line we were drawing? We said that there is some overall intercept, okay? And then you can have one group which has this difference, okay? And you can have another group. So this is group 1, this is group 2. So you can say, what is gamma 00? This is your gamma 00. Okay, this is your gamma 00. What is this? This is your U01. Okay, and this one, let me draw this better. Let me just erase this. Okay, and let me use a different color. This is for group 2. So we can say, let's call this as the group 1 line. So this overall is your gamma 00. This second, this difference, not this difference is U02. This difference is U01 and so on. So gamma 00 is nothing but overall intercept in this, and then U0j is capturing the variation. So this term is capturing the variation in intercepts per group. This is capturing variation in Yij per individual. This equation is called as an L2 equation because here you see there are only j terms. L1 equation has both I and j, right? If we combine, so we get, combining, we get Yij is equal to gamma 00 plus U0j and Rij. So you have these three terms. And this, why is this called as null model? Null model because there are no explanatory variables. So a null model has no IVs, no IVs. That is why it is called as a null model. Now this gamma 00 is called as a fixed effect because it is telling us, it is giving us some overall number, which is the overall intercept. So it is called as a fixed effect. And U0j and Rij are capturing the random effects or residuals, right? So these are called as random effects. So in one equation, therefore, you get both fixed effects and random effects. That is why we also call these models as mixed effects models, right? They are capturing both fixed effects and random effects. Now, what is the variance of U0j? Let us call this as sigma U0. The variance of Rij, let's call it as sigma R. Okay. So what we get, okay, or let's call it as, yeah, what we get in terms of the ratio, okay, let's call these as actually, yeah, sigma is st, let's call this as sigma square u0 and sigma square. Sigma is typically used for standard deviation, so we'll call these as. Now let's come to the first coefficient that we were talking about, ICC1, intra-class correlation coefficient. 1 is nothing but, we say, sigma square u0 whole divided by sigma square u0 plus sigma square r. This is a very important result that we have got. We say, what is this? What was it capturing? It was capturing variation at group level, right? L2 level. And this was capturing variation at individual level. Individual level. So what is the interpretation or understanding of ICC now? We say ICC1 is telling us proportion of variance in dV that can be attributed to L2 level L2, right? This is correct. Let's call it as level. So Kanika was asking, right, at the beginning, Kanika asked
Yes, sir.
question that how do I know what is the impact of work engagement, or what is the impact of organizations at work engagement? We get, that is why the first step is we do the null model testing. Null model testing itself will give us how much variation in work engagement or your DV is actually because of is because of level 2 variable, is because of the variation that is coming because of the group. You are not including any predictor here, right? That is what we are doing. We are not doing any predictor. If I were to draw the conceptual diagram, I will, while we don't draw, but if I were to represent this, I would say this is my Yij, and I just want to understand what's the contribution for onto Yij at both, uh, because of L1 and L2. How much variation can you? So ICC1, I have broken down the variation of Yij into two levels, at level 1 and level 2. So if ICC is, let's say, comes out to be zero point 0.2, that means you can say that 20% is because of L2, 80% is because of L1. Is this making sense? This is the first step of multi-level model. This is the first set of equations, or you can say the mathematical formulation that we built. And it's a very simple, no IVs. You just say there is some overall intercept, gamma 0, 0, and then there are some variations because of group and because of uh, individual. Is this okay? Any questions here? We can take that now.
So again, the question here now, can this be run for 15 groups?
Yes, you can.
Okay.
You can do it because
Oh,
you see, you are not doing anything, just breaking it down into
group.
removing the you are not bringing in any predictor, so there is no question of power and stuff like that. So you can just
Okay,
say,
sir.
I just want to understand what's the variation across groups here.
And the result that we get, the only way to interpret it is what you said, that 20% of the
Yes,
effect is explained by
yes,
the group
and there
level.
is yes, and there is no threshold here. Okay, so there is no threshold. Obviously, if it is ICC one is zero, that means there is no impact of level two. If it is zero point 0.1, then you are saying there is 10% impact. If there is 0.05, you are saying 5%. Now it's up to you whether you consider 5% is high enough or 10% is low enough. In general, we say anything above 10% is worth exploring. That means there is 10% variation because of some level 2 phenomena.
Right, sir. Okay.
But
Thank you.
let me tell you, in literature there is no such threshold. Any number of ICC, we just say, well, this is what we have, right? You may go
Noted.
further and explore further, or you may just leave it and say that I don't need to explore because I consider there is not much level to influence in my DB. Yeah. Yes, Deepak.
Yes, I understand about the formulation. I'm just curious to know from where that null model equations are coming. Maybe they have deliberately attempted to make it in the form of y is equal to a plus bx, but they are, as predictor is not there, they are not actually in that form maybe.
Yes, absolutely. So it is a normal regression equation without any IV.
IV.
That's it. So L1 equation is saying Yij is some constant plus residual, right?
Yeah, yes,
And then now you also have to write the equation for beta 0 because you have to say how is this intercept varying across groups, right? So that is
yes.
what we write, that this intercept now varies. There is some overall gamma and it varies like this. This is what we are saying. This is the L2 equation that we are writing.
Okay, so there is some value and
And
that can be attributed to both L1
there
and
is an overall intercept, okay, and then these vary. Each group has its own variation from the overall gamma 0 0.
Sir, what is group 1, group 2 here?
What is
Group 1, group 2.
what is group 1, group 2? Well, it is not just group 1, group 2. You may have n number of groups, right? So L2 is, let's say, so you have collected data from group 1 or team 1 or team 2. Say you have collected from 30 teams. So you will have U01, U02 going up to U030.
Mhm. Okay, okay.
Right, so this group is essentially your how many groups, or if it is organization, then how many organization, if it is team, how many teams, if it is school, how many schools, and so on.
Effect of their variation on our
Yes,
individual
yes.
data. Okay.
So you are saying how is this intercept, which is beta zeros j, varying across groups, varying across teams,
Across the group.
varying across schools? That is what this equation is modeling.
Okay. Thank you, sir.
Uh,
Yeah.
sir,
Yes.
those varying intercepts, don't you think that should be the straight lines than being a sloped one? Because, the
Where is
variations
the
across
slope?
group,
Huh?
the group one, group two lines,
Huh?
the mean value for a particular group is the intercept value is constant for all the observations, right?
What is an intercept? What is an intercept?
It's the mean value of that dependent
Of
variable
that group, of that
of
group.
that group.
Yes. So
So
what is beta 0j? It is nothing but the average of Yij for group 1, correct?
right, yeah,
Beta
yeah.
zero
So
two
I
will be,
mean, if you can clarify what is the x value here, I mean the
what is the?
x axis here in the
Huh,
graph. So it's, let's say if the number of observations or the
yes,
observations.
yes,
So I mean, that mean value will be constant for all the members across the group, right?
yes, yes. So here it is some x, right?
Right,
Some predictor. But here we are, so what is the null model doing? Null model is only talking about this intercept,
right, okay.
correct? We have not yet modeled the slope at all in this equation. We are just talking about how is the mean varying across groups.
Okay, okay.
Yeah. So there may be a slope, there may not be a slope, but you are right. We should make it very clear that the null model is only interested in talking about what is the variation in this mean across groups,
Sure, sir.
correct? The lines could be straight, lines could be upward, lines could be downwards, we don't know, and we are not bothered at all in step number 1. We are just talking about what's the overall mean and how is the mean of the group varying with respect to the overall mean. Yeah, you can also say gamma 0 0 is actually nothing but overall mean of all Yij's, and your beta 0 j's are means of Yj's in group J. Is this making sense
Yes, sir, sure.
to everybody? Gamma 0 j is nothing but overall mean of all data, and beta 0 j's are nothing but means of Yj's in the group J. That's it. And what is the U0j capturing? It is capturing gamma 0j, this beta 0j's minus gamma 00, right? That's it. How is each group varying with respect to the overall mean of the equation, of the overall mean of all Yij's, of the Yij's. Okay, should we proceed? Is this making sense? Yeah. Take a look at this for a minute and see if you have any more questions, and then I will move forward. If anybody has any questions, you can ask. All right, so we go forward, and let us go to the second step. So we call it as step number 2. Step 2. So first was null model. Now we say the step 2 is random intercept intercept model. Now let me draw, because this is our first time, so we should also have the diagram in front of us. What is it that we are saying? We are saying Xij impacts Yij. This is at L1, and then you have Wj. Now because I am just talking about random intercept, I am not talking about cross-level interaction. I'm just saying why Wj also impacts Yij. Right? This is the model. This would be the diagrammatic representation of random intercept model. Now, what is my equation? I say Yij is equal to beta 0j plus, let's bring in xij now. So there is a predictor xij plus rij. We know this is our L1 equation because in L1 equation you have all L1 variables. So we have xij, we have yij, which are both L1 variables. Now we want to talk about both our intercepts and slope, and we are at the moment saying only intercepts are random. So what do I say? I say beta 0j, I say gamma 00 plus u0j, okay, and then I say beta 1j. I am saying slopes are not random at the moment, so I hold it at some constant. Okay, these two become my L2 equations. So because this is slopes, we are saying slopes are fixed, they are not random. Only intercepts are random. So combining, what do we get? Combining, we get, you get Yij is equal to gamma 00 plus gamma 10 xij. And you should also observe that I'm writing what is the notation. We say gamma 00. So the first 0 is coming because we are talking about beta 0, and then this is the first variable, so 0 0, just like we had beta 0, beta 1, and so on. Here gamma, the first coefficient comes because we are talking about beta 1, and then 0 comes because we are talking about the first variable in the equation of beta 1j, so gamma 10, and then you get u0j and rij. Now, can anybody tell me how many fixed effects are there in this equation? You can say this is our multi-level equation. How many fixed effects in the multi-level equation? And how many random effects? Anybody?
So 3 fixed effects.
Anybody else? What are the 3 fixed effects, Kanika?
Oh no, it's only one. Slopes are fixed. No, you said.
No. What is a fixed effect for which you actually get a coefficient, get a actual
That way
constant?
there are two then.
Two there are.
There are two, right?
Yeah.
You get gamma 00 as an output,
And 10 to xij.
and you
Yeah,
get
right.
gamma 10. This is, you can say, this is the overall mean
Intercept.
of data, or you can say overall intercept or overall mean, correct? And what is this? This is the overall
Slope.
slope, correct? What is this? Capturing the
Random.
variation in means, or we can say intercepts across groups. And what is this? This is variation in Yij across individuals. Correct? Or we can say this is nothing but a residual of regression. Correct? So how many fixed effects are there? There are two fixed effects. How many random effects are there? There are two random effects in this equation. Is this okay? Right? So this is random intercept model, but we have not yet brought in WJ, right? This model would be represented simply like this. We will say, we will draw it as Xij to Yij, and I am saying there is a L1 and there is a L2. That's it. We have not yet brought in Wj. We want to know what is the impact. Does Wj actually explain my variation in intercept? That is what, does Wj actually explain the difference in overall mean? That is what is my interest. So what do? I go to, let's call this as step 2a. This is step 2a. Now we go to step 2b and I say Yij is equal to beta 0j, beta 1j, xij plus rij. This is my L1 equation. Then I say what are going to be my L2 equations? I write them. Beta 0j is equal to gamma 0 plus gamma 01 wj plus u0j, and beta 1j continues to be gamma 10 because we have said it is a random intercept model only. There are no random slopes as yet. So these are my two L2 equations. Combining, what do we get? We get combining, we get Yij is equal to gamma 00, gamma 01 wj plus gamma 10 xij plus u0j and rij. This is our multi-level equation. Now, how many fixed effects are there in this equation and how many random effects are there in this equation?
Three fixed, two random.
Yes, anybody else? How many fixed effects are there and how many random effects are there in this equation? What is a fixed effect? When we get the coefficient of our predictors of our IVs. So how many coefficients we get? Gamma 0, 0, gamma 0, 1 and gamma 1, 0. So there are three fixed effects and how many random effects are there? We get two random effects. Therefore, if you see in multi-level papers, you will not get betas in output. You will actually get gammas. If I were to now draw this, let us draw our model. Okay, how will you draw this in your paper? You will say my Yij and Xij. Okay, and you have your Wj now. So you have your L2 and you have your L1. So Xij to gamma ij, what is the coefficient? It is, you will call it as gamma 10 in your diagrams and models. And then Wj to Yj, what is the effect? It is gamma 0, 1. And the mean overall intercept is gamma 0, 0. What is the between group variation? We can also call this as between group variation, right? It is the variation in the means between groups, and this is the residuals, regression residual. So if you were to now, after your multi-level modeling, if you were to now draw this model, you will not write in terms of beta 0, 0 or beta 0 or beta 1. Rather, you would be using these notations of gamma 0, 1, gamma 1, 0 and so on. So in your tables outputs, you will be talking about the gamma coefficients as the impact of L1 and L2 variables after you have written and modeled multi-level data, multi-level equations. This is what the coefficient is and this is what we are explaining. So overall residual also, you see, we have now been able to partial it out in terms of the residual that is at the individual level and the residual that is at the group level. Is this okay? Is this making sense? Any questions here? Then comes the last step. Let us do the last step of our modeling. Okay, this is the final step of multi-level modeling where we do step 3, which is now random slope and random intercept. What is the diagram? You have Xij now and not Wij, Yij, and you have at level 2, this is your L1, at level 2 you have Wj, which is impacting both intercept and is also impacting the slope. So now you have a cross-level interaction term, right? Cross-level interaction term that we will have to model, and this is called as L2. Let us write the equations and see. So we'll again call it as step 3a. We will write Yij is equal to beta 0j plus beta 1j xij. Level 1 equation, there is no change. There is an IV, there is a dV. This becomes our L1 equation. Now beta 0j, we had said it is gamma 00 plus gamma 01 Wj plus U0j. Right? This is what we had done in our previous step. In step 2b, we had written that the intercept is some overall intercept plus the variation because of Wj. Now I will say beta 1j. Now the slope is equal to some overall slope gamma 10, some overall slope plus there is some variation, and I will call it as the variation as U1j. If you look at this, so this is, we say, overall slope, and this is variation in slope per group. These are our L2 equations. Combining, what do we get? Yij is equal to gamma 00 gamma 01 Wj plus gamma 10 Xij plus U0j plus, now you see, if I put beta 1j as gamma 10 plus uij, I will get gamma 10 multiplied with xij, and I will also get u1j multiplied with xij. So I get u1j multiplied with xij plus rij. I have replaced beta 1j with this equation, correct? So what will I get? Gamma 10 multiplied with xij, and I will also get u1j multiplied with xij. So I get these two terms. How many fixed effects are there in this equation? Who will tell? And how many random effects? There are again 3 fixed effects now, and there are 3 random effects, because one random effect is because of random intercept. This is random slope effect, and this is the residual. Now, one last model that we will do is, up till now we have still not explained what is the cause of randomness in the slope. We had just said that there is some randomness. I want to say in my model that Wj is the source of this randomness actually. So what will I do? I will go to step 3b. And what am I going to write? I'm going to say Yij is equal to beta 0j plus beta 1j xij plus rij. There is no change in the L1 equation. Then I say beta 0j is equal to gamma 00 plus gamma 10 wj plus u0j. And now I am going to say beta 1j is equal to gamma 10, some overall mean of the slopes, plus, sorry, this will be not gamma 10, it will be gamma 01. Here I will get gamma 11 wj plus u1. So this is my L1 equation, this is my L2 equation. Okay, now when I combine, we say combining, we get Yij is equal to gamma 00 gamma 01 wj. Then I will put u0j later, but now I will multiply whole of all the three terms with xij. So what do I get? Gamma 10 xij plus gamma 11 xij multiplied with wj plus, now I get u0j u1j multiplied with xij plus rij. Now what are the fixed effects in my model? I get 4 coefficients because there are 4 predictor terms that are there in my equation. So I get 4 fixed effects and I get 3 random effects in my model. If I were to draw this, and if you do this kind of an analysis and then you have to report this in your research paper, what would you say? You will draw it like this. You will say I have my Yij, okay, I have my Xij, then I have my cross level, this is cross level. Now I have Wj, and I also have an interaction term which is Xij, just like you in moderation. So you have an interaction term Xij multiplied with Wj. So what is Xij to Yij? This is given by gamma 10, this term. What is Wj to Yij? It is given by this coefficient. So you write this is gamma 1. And then what is this interaction term to Yij? This is this term. You say gamma 1. And then you have the 3 residuals that you have reported, and you know the variance of those residuals. This is your final overall model that you wanted to test, and Now you have been able to account for the multi-level data structure that we have. You have been able to account for the multi-level analysis. You have been able to break down the error terms in terms of errors at the individual level, errors at the group level. And this is the final, you can say, the most advanced model that we will be modeling and testing. Any questions here? Anybody has any questions before we take a break? Yes.
So just a very basic question, which is now here I understand that here you've set the context for the next a few days, but this interaction effect that we are measuring here is not a necessary condition. It only
Not a
depends on the
necessary.
research.
Yes, absolutely.
Yeah.
See, I
Okay.
could have stopped at any place. I could have
Yeah.
just stopped at null model. That is also
Right.
fine. I could
Right.
have just stopped at in random intercept model. That is also fine. I could have just stopped at step 3a also. I said that the slopes vary, but I don't want to explain why do they vary. Okay. Or I
Right.
can also stop at the slopes vary, and I can also explain why do they vary.
Hmm.
That is the most advanced. So I can show that the means vary, and why do they vary is my random intercept model. I can also show that the slopes vary, and why do they vary is what I am showing in my random slope. And you can see, you can also say, you can also write beta 0 j is
Hmm.
equal to gamma 0 0, and you can say beta 1 j is equal to gamma 1 0 plus gamma 1 1 wj plus u1 j. What does this become? This becomes only a random slope model. There is no random intercept. Intercept is fixed, right? So
Got
it
it.
is it is up to you. In general, when we model random slope, we also check whether there is a random intercept. But I could have also written this equation and it would have been perfectly fine.
Sure, sir. Thanks.
Yeah. Okay. So this is what I have uh, put up in the presentation. Okay, and I will share this presentation to you. Three classes of multi-level models. Okay, this system of equations. Okay, the means as outcomes. Okay, so you see it is simply gamma 0 0, and here I have not here in this, you see this is another variation Kanika and everybody. Here there is no x variable in L1, you see, but then I want to predict what is the variation and why is the variation in the intercept. So this could also be possible. This is the model we wrote where we said beta 0 j and beta 1 j xij, and then I say beta 0 j is equal to gamma 0 0 plus u 0 j, and beta 1 j is gamma 1 0. Correct? And the last
Got it,
is
sir.
this system of equations that we have just done, where you model both as changing, but you don't explain why are they changing. Whereas here, beta 0 j, there is wj, and beta 1 j also there is a wj. Okay, and that is what we get here. This is from the book Luke 2004 that I had also mentioned as a reference text. And okay, so let us take a pause here. We will stop and If there are any questions, I can take them now, or else I will upload the recording as well as the presentation till what we have covered. You can take a look, okay? And in terms of readings, let me share with you my screen. Just give me a minute. In terms of readings, if anybody wants, so in the multi-level folder, okay, you can read this paper, this not this one, Brown et al. This is a research paper, leadership, transformational leadership, job satisfaction, and team performance. Okay, and read in terms of theory what we have discussed, and this is the model. You see, now you will be able to appreciate what is going on. You see, there is a individual level model, which is leadership to job satisfaction mediated by trust. There is a level 2 model only, which is leadership to team performance and trust. And then they are saying whether transformational leadership impacts job satisfaction, whether trust in team impacts job satisfaction. Okay, so read this paper, and then this paper, this document, Blees 2007 multi-level modeling. Okay, don't read everything here. Let me just take you to the, yeah, you can read the example from page number 3.3 given on page number 30, regression and contextual OLS model. Okay, and you can just read the example. Okay, ignore the syntax, just go over the reading. And then if you have the if you have the Luke book, okay, if you can get it, I have shared with you the full number. If you can, then you can read the first need for multi-level modeling, which I have generally covered. Okay, so page number 1, 2, 3, 4 and 5. Okay, so the first 5 pages, and then the Heck et al. Book, again, which is on SPSS, but chapter 2, chapter 1 is the introduction. Okay, yeah, page number 75. So let's go to page. This is also the example that we will be covering, okay, from single level to multi-level analysis. So this is something that you can cover. Okay, just read the few basic first, and then it talks about building a 2-level model. Okay, yeah, you can download these books if you can, or if you have in your library, you can check and just go over these. I will share the recordings and the presentation. Okay, so let us stop. If there are no further questions, just think about it and what we've discussed, and we'll come back at 3 p.m. tomorrow and continue our discussion.
Thank you, sir.
Thank you.